Today we are learning about this sine function. The transformations are we move up 1 unit, it is reflected over the x-axis, we move left pi over 2, and it is also expanded horizontally. The amplitude of this function is the absolute value of a, so that's 1. The period is 2 pi over the absolute value of b, so that would be 4 pi. The phase shift is negative c divided by the absolute value of b, which is negative pi. So based on this information, we multiply, because of the transformations, we multiply x by 2 and subtract it by pi over 2. Also, we take the negative of y and then add 1. So we go down to the table. Now we plot the points. The first point will be negative pi over 2 and 1. The second point will be pi over 2, 0. The third point will be 3 pi over 2, 1. This point is 5 pi over 2, 2. This other point is 7 pi over 2, 1. Now we need to draw one more period, so we're going to follow the exact pattern. Now we are going to plot the point negative 5 pi over 2 and 1. The next point will be negative 7 pi over 2, 0. Now you connect the dots.
It's like a big M.
You can tell it's a sine function graph because the parent function graph crosses the origin and the two ends go the same direction. For this one, it is down. But this graph, since the coordinates were translated up 1 unit, it does not pass through the origin.
Now we're going to graph a tangent graph. Woo! Alright, so the transformations are, it's vertically expanded by 2, and it's also horizontally expanded by 2. The amplitude is none.
Why is the amplitude none?
Well, it's because the domain in a tangent graph is not continuous. The range is. Now, the formula to find your period is pi over the absolute value of b. So, we've got pi over 1/2, which equals 2 pi. Your frequency is your period just inverted, so it's 1 over 2 pi. Alright, now we need to find your phase shift, but there is no phase shift.
Why is there no phase shift?
Calm down, I was getting to that. If you see in this formula, we don't have a c to this function. So therefore there is no phase shift because there is no c.
Okay.
So now we're ready to start finding our points. So what you're gonna multiply the x by 2, and then you're also gonna multiply the y by 2. So starting out with these first points, because they're the normal tangent points, and so you're gonna multiply negative pi over 2 by 2, which equals negative pi, and then you're going to multiply negative pi over 2 by 2, and negative 1 by 2, which equals negative 2. And now we have a toughie. 2 times 0. What's that, Rachel?
0.
And again?
0.
Whoa, that looks like the origin. And pi over 4 times 2 equals pi over 2. And 1 times 2 equals 2. And then your x asymptote is 2 times pi over 2. And that equals pi. So here are your asymptotes every 2 pi. Got negative 3 pi, negative pi, pi, and 3 pi. Your vertical asymptote is 2 pi because it's being horizontally expanded by 2. So now we're ready to start plotting our points. So our first point is negative pi over 2 and negative 2. So negative pi over 2 and negative 2 is down here. Yep. We've got 0, 0. I was right. That is the origin. Got pi over 2 and 2. And now we've got 1 period done. Cool, huh? Okay, now you do the exact, you repeat the pattern. So we've got 2 pi and 0, 3 pi over 2 and negative 2, 5 pi over 2 and 2. Okay. And those are your 2 periods. I guess I'll draw 1 more period though. So, negative 2 pi and 0, negative 5 pi over 2 and negative 2, and negative 3 pi over 2 and 2. And now we have 3 periods of your tangent function. And now we finished graphing the tangent function. Now I'm going to turn into Joglo.
Alright, so now we've got a third function here. Now we're using secant transformations for this graph. Going left, pi. Since there's a negative, reflect x-axis, and right here is a vertical compression by 1/2.
Ooh.
Alright, so as you can see there's no amplitude in this function.
Wait, what's the amplitude
No
again?
amplitude, there's none.
None whatsoever.
Alright, so now we're going to move on to the period. It's 2 pi over absolute value of b. So 2 pi over 1, which equals 2 pi. So frequency, absolute value of b over 2 pi, which equals 1 over 2 pi. So the phase shift is negative c over the absolute value of b. For this one, it's negative pi over 1 or negative pi. So the vertical asymptote.
Miss Schreiner says asymptote.
Okay. Anyways, the asymptote for the parent function is x equals pi over 2 plus pi over n. So to find it for this function, it's going to be x equals, going to use the pi over 2, subtract pi from up there, 2 pi over 2. So x equals negative pi over 2 plus pi n. So now we have our table over here with the secant points. So now we're going to do transformation using this right here. X for For this one, it's going to equal negative 3 pi over 2, since you're subtracting negative pi over 2 from pi. This next one, negative pi, negative 1/2. Third one, x equals negative pi over 2. Fourth point, 0 and 1/2. And the fifth point, x equals pi over 2. So now, using these points right here that we just found out from the parent function, we're going to graph the function. So we have we're going to have asymptotes at every pi over 2. Now just use the points, put them on the graph. Negative pi. Whoops. Gotta do this. The y. Zero 1/2. Alright, since this point is below the x-axis, our graph will also be below the x-axis and negative, and since this one is above the x-axis, graph will be pointing up. Now this is only one period of the function. We need to do one more, so you just use the same y coordinate from the first points and just move them over. And there's your secant function.
But Joe Glow, how is that different from a tan function?
Well, let me go call Miss Schreiner. Well, I just got off the phone with Miss Schreiner, and she told me that a tangent graph has a range of all real numbers, while a secant graph, this one here, does not have a range of all real numbers. For this graph, the range is from negative infinity to negative 1/2, and then 1/2 to infinity.
And that concludes our segment of graphing tan, secant, and cosine functions.
Pretty sure it's sine function.
Whatever.